By default, the RNA-seq pipeline will generate a mutation report from your RNA-seq data. You can also generate a report directly under NGS, Variation, Summarize Variant Data. This will give you much more control over the cutoffs for calling a variant and the way that the variants are reported. For example, you can reduce the number of reads covering a base and the number of reads containing a mutation. You can also exclude low mutation frequencies and choose to output a merged or individual VCF report in addition to or instead of the standard summary report. Mutation reports can be quite large, so they are streams from the server instead of being downloaded directly to your cache. For each variant, the mutation frequency, coverage, and predicted genotype are reported for each file. You will also find basic information about common SNPs reported in dbSNP. We can also add additional annotation sources to our variant table. Go to NGS, Variation, Annotate Variant Table Report. You can choose the reference sequence, gene model, which report columns to include, and which annotation sources to use. If you generated a VCF report or have an external VCF that you'd like to annotate, you can also do so under NGS Variation, Annotation Variant File, or VCF Data Object. An advantage of VCF files is that they have many more classifiers for variants, such as the gene, location, and the frequencies. And these streaming files can support up to 1 billion variants. Let's filter for the gene BRAF. There are 5 reported variants. We can see that some variants are synonymous while others are non-synonymous. Let's look at the annotation for more details. V600E is classified as pathogenic. We can see additional details from each file in the Details window. Let's look in the genome browser. You can add BAM files directly from the server. We can split each file into separate tracks by right-clicking and choosing Split into Multiple Tracks. On the left, select Apply to all tracks and Show Variation. You can see that multiple files have the V600E mutation. We can also directly view the sequences underlying this. we were just looking at this track, which has an alternate allele frequency of 0.6.